Welcome back. The next topic we have to discuss is actually internet routing. But before that, I think we have to discuss something about the complex structure of this network of networks. Network of networks means the internet network, right? And the greatest example for this internet network is our internet itself. So we will focus on how this internet is actually organized, what are the basic components of internet, and how this ISP provides this network connection to this internet like that. So let us start from the end systems or edge of this network, that is our end systems. So end systems can be anything like PCs, smartphones, web servers, mail servers, etc. And these end systems are connected to this internet through some internet service providers, right? ISP in short. And these ISP can be called as access ISP. So the ISPs which connect our end system to the network, that is called access ISP. Access ISPs can be some residential ISPs like local cable or telephone companies, or it can be corporate ISPs or universities ISPs to provide connections to the faculty and students, or it can be ISPs that provide Wi-Fi to airports, hotels, or it can be some cellular data ISPs providing mobile access to our smartphones, right? Each ISP is itself a network of packet switches and communication links. Okay? And this ISP provide a wide variety of services, like it can be some broadband access such as cable modem or DSL, or high-speed local area network access can be there, or mobile wireless access can be there. And these ISPs provide internet access to content providers like Google's and all, and to connect their websites and video servers directly to the internet. That is also done by this ISP. The internet is about connecting all the systems to each other, right? That means all the systems should be interconnected. That means this ISP should be connected together. That forms the network of networks. So a naive approach for connecting these access ISPs together is to form a mesh here. That is, from every access ISP there should be a communication link to every other access ISP. Okay, but the problem here is that will be very costly for access ISP, right? Because there can be hundreds of thousands of access ISPs all over the world, and to get a communication link to each and every access ISP will be a very costly one. So we have to move for another structure. The solution is to form a hierarchy of ISPs. We can see here that the access ISPs here are joined together into a regional ISP or local ISP. Span of a particular region ISP depends, right? So just for example, we will assume that for every city there will be an ISP, and this ISP will connect all the access ISP in that city, in that region, and all these regional ISPs will be connected together to the next level, that is called national ISP or global ISP. Global ISPs are provided by companies like AT&T, Sprint and NTT, and they form a very high speed network with high speed routers interconnected with high speed fiber optic links. 10 to 12 different national ISPs are there currently in internet. As a summary, this is the interconnection of ISPs over the internet. Different tiers are there. The uppermost tier, that is national ISP or global ISPs, that forms a very high speed network with high speed routers and high speed links. Sometimes they directly provide connections to some content providers and all. So Google, you can see here, directly connected to this national ISP rather than going to this access ISP, right? So it will be provided with a very high speed network connection. And these tier 1 ISPs are actually used to connect regional ISPs, right? And regional ISPs are connecting access ISPs. Okay? And access ISPs provide internet connection to our end systems. This is the overall structure. And in between you can see some IXP, right? That is Internet Exchange Point. We will see what's the purpose of that later. Now let us be familiar with some terms which are used in this interconnection of ISPs. First one is point of presence. We have already seen that earlier sessions, right? And point of presence is actually a group of one or more routers at the same location which are grouped together or linked together in the provider's network, where the customer's ISP can connect into the provider's ISP. In the ISP hierarchy, there should be a connection from the customer's ISP to the provider's ISP, right? And that point is called actually point of presence. Just for example, here this access ISP is getting connected to the regional ISP in this point of presence. Okay, like that this regional ISP will be connected to this national ISP through this point of presence. So that usually this customer's ISP will lease a high speed link from a third party, maybe a telecommunication provider, to connect one of its router to a router in this point of presence. This point of presence is actually part of the higher level ISP. And the next term is multi-home. Multi-home, as the name suggests, multiple homes will be there. So for access ISP is a customer ISP, whereas regional ISP is a provider. For regional ISP acts as the customer ISP and the national ISP acts as the provider ISP. So any ISP except for tier 1, the highermost will be exception. Other ISP may choose to multi-home. They may connect to 2 or more provider ISPs. An access ISP may multi-home with 2 regional ISPs, or it may multi-home with 2 regional ISPs and also with a tier 1 ISP, national ISP directly. You know the benefit of this multi-home, right? Yeah, availability, robustness, etc. That is, even if one of the ISP fails, it can continue access the internet through the other ISP. Yeah. And the next term is peering. Peering, as the name suggests, directly connecting the ISPs in the same level. Okay, so pair of nearby ISPs at the same level of the hierarchy can directly connect their networks together, so that all the traffic between them passes over the direct connection rather than through the upstream intermediaries. So as you know, this access ISP should pay to get the service of regional ISP, right? And the regional ISP should pay to get the service of this global ISP. And the amount paid depends on the traffic exchange between these customer and provider ISPs, right? So definitely that will be costly and all. To reduce this cost, a pair of nearby ISP can directly connect. That is called peering. So in that case, if peering is done, traffic can be exchanged without any cost. A mutual agreement will be there. And the next point to be discussed is Internet Exchange Point, or IXP, which is a meeting point where multiple ISPs can peer together. Okay, and IXP is typically a standalone building with its own switches. Okay, and there 2 different ISPs in the same level can be connected. So we have seen how the ISP is actually arranged in a hierarchical manner, right? Now let us think about the actual systems in our internet network. Okay, how they are arranged, and the main topic we have to discuss is routing in the internet network. Okay, and we have already seen how the routing can be done within a single network, right? That was a major function of network layer is routing, and that can be done using different algorithms like distance vector algorithms and then link state algorithms like that. So you may think, why can't we extend the same routing algorithm for the entire internet, right? Yeah, but that is not practical because of 2 different reasons. First one is scale. Okay, as the number of routers in a network become larger, definitely the overhead involved in communicating, computing and storing routing information becomes prohibitive, right? Remember the 2 different cases, that is distance vector routing and link state routing. In both cases, we have to store the information about all the routers in every router, right? Routing table should be there, and they have to exchange information periodically about all the other routers. Okay, so and today's internet consists of hundreds of millions of routers. So storing routing information for all possible destinations at each of these routers definitely require infinite amount of memory. And also the overhead required to broadcast link state packets and all will be a very complex task, right? In case of distance vector algorithm, iteration is done, right, to converge the algorithm to fix a routing table. That will also take a lot of time to converge. So definitely something should be done to reduce the complexity of route computation in a network as large as the internet. Next reason is administrative autonomy. As you know, this internet is actually a network of ISPs, right? So with each ISP, it consists of a set of network of routers, right? So definitely an ISP generally desires to operate its network as it wishes, or to hide some aspects of its network's internal organization from the outside. In an ideal case, an organization should be able to operate and administer its network as it wishes. At the same time, it should be able to connect its network to the outside networks. Both of these reasons led to organizing the entire set of routers inside the internet into groups called autonomous systems. Autonomous system is actually a group of routers that are under the same administrative control. Maybe that same ISP. Okay, so the routers in an ISP and the links together that interconnect them constitute a single autonomous system. And each autonomous system will be identified by its globally unique autonomous system number, or ASN. And these autonomous system numbers are assigned by regional registries managed by this ICANN. ICANN stands for Internet Corporation for Assigned Names and Numbers. That's the organization responsible for assigning this IP address, domain names, and this ASN, etc. And then again, that power is delegated to different subcategories. We will see those things. So ICANN is a non-profit organization headquartered in South California that was started in 1998 to help the US government manage certain functions that maintain the Internet's core infrastructure, like maintains a central repository of IP addresses and helps coordinate the supply of IP addresses, manage domain name systems and the root servers in this ICANN repository. And currently it manages over 180 million domain names and 4 billion network addresses across 240 countries. As you remember, this DNS, domain name system, is actually used for mapping between IP address of a machine and its corresponding domain names. Why we are using such a thing? Definitely just like a phone book, right? We don't need to remember all the phone numbers. Instead, we can save that number with a name. So we can search for a name to get the number, right? Like that, every IP address, like some servers and all, it will be mapped into some URL, and that corresponding domain name server will store the information regarding which IP address is mapped to that corresponding names and all. So these autonomous system numbers are actually assigned by this regional registries, right? That is managed by this ICANN. So what is actually a regional registry? So entire world is divided into 5 different regions. So corresponding to each region, there will be a registry, okay, and that manages all the autonomous system numbers and IP address under that region. These are the 5 different RIR over the world: ARIN, RIPE NCC, APNIC, AFRINIC, and LACNIC. You can see the full form of these. African Network Coordination Center, then Asia Pacific Network Coordination Center, American Registry for the Internet Numbers, Latin American and Caribbean Internet Address Registry, and finally we have the RESOX IP European Network Coordination Center. So these are the 5 different registries, and there can be some hierarchy in between, each RIR, that is each regional internet registry, may be again further divided into a set of local internet registry, like that. So again further divide the addresses into that corresponding local area. So if a particular autonomous system, or if a particular ISP requires an autonomous system number, it should be applied and it should register within the corresponding internet registry to get the corresponding numbers. And what do you mean by number resources, right? That is internet number resources include IP addresses and autonomous system numbers. So IP addresses for different machines, and also autonomous system number for the entire autonomous system managed by ISP. That both are assigned by this regional internet registry. Now the task is called simplified, right? That is, the entire set of routers within the internet is now divided into a set of autonomous systems, such that all the routers controlled by a single entity, maybe a ISP or a very large organization with independent connections to multiple networks. Okay, that forms an autonomous system, and the condition here is that all the routers within an autonomous system should adhere to a particular routing policy. Particular routing algorithm should be there, and that choice of routing policy can be decided by the corresponding authority. So of course different autonomous system may have different routing policy, right? So both issues are addressed here, right? Scaling and also administrative autonomy. Let us move to the actual task, that is routing within the internetwork. Now it is simplified into 2 different types of routing. First one is intra-AS routing, that is how to route different packets within an autonomous system. Inter-AS routing means routing among different autonomous systems. In that case, each node will be the entire autonomous system, right? We will see the details in the next session. Thank you.